Hey folks, my name's Drew DePalma. I lead product for Realm, and today I'm going to be talking a little bit about building better apps faster with Realm. Now, typically when we talk about Realm, there are really sort of two key pieces to it. The first is looking at your application and the device that it lives on, and for that we have the Realm SDKs. The Realm SDKs provide a mobile database just optimized to live within your application and on your device, giving you local storage and the ability to interact with your data within your application. And they also provide hooks to the cloud, specifically MongoDB Cloud and MongoDB Realm, a set of serverless services which make it easier to build applications. Specifically, we're going to be talking about sync, some of the security services, triggers, and APIs. And what we're going to talk about today is a little bit about how these services and the Realm SDKs give you the ability to build better apps faster. So let's break that down a little bit. What do we mean when we say build better apps faster? Well, in our mind, when we think about better, it's providing you a lot of the base logic that you would have to write for an application. Think data movement, validation, security, in a way that's optimized for best practices and is ready for you to use out of the box. We've also focused on making the cloud pieces serverless, managed, and scalable, meaning that as you start out, as you POC, develop, or test, it's really easy to just take your app from zero to production. And finally, we've designed each of these pieces to be flexible and extensible, to be able to live on their own or in combination, and to be able to work alongside other tools that you may already be using in your development experience. When we talk about faster, it's typically the speed which you can write features and the ability for you to actually get your code to production. What that means is taking the way that you model data and making it the same across MongoDB Atlas, across your business logic, living at the server layer, and across your SDKs. Also means less glue code, less passing of data, manipulating formats as you go to the different layers. And because we know that, as you're building an application for production, it's not just one, set of code, it's not just one feature branch. It's making that pass of code from development to deployment to testing really simple. And we're going to dive into each of those pieces. So first, starting with the SDKs. So I said that the SDKs were really a way to work with your data locally and integrate it with your application. Really, what they contain is a full standalone open source mobile database. So this is something that you can use to persist data in an app without using the cloud. It's used in tens of thousands of applications today. And what it lets you do is model all that data that you're persisting as native objects, gives you query capabilities, ability to really easily manipulate that data, and is available across all of the platforms that you're likely developing for. Everything from iOS with Swift and Objective-C to Android with Java, Kotlin, .NET, including our newly GA'd Unity support, and also JavaScript libraries such as React Native, Electron, working with the Raspberry Pi. And we've also started to look at some emerging cross-platform frameworks as well. So specifically Kotlin multi-platform and Flutter. And what this means is that as I talk a little bit about the features that are provided with the Realm SDKs, all of these features work pretty much the same regardless of which platform you're using. And if you're developing for multiple platforms, it means a lot of your data models, your code is easy to port across. So we talk a little bit with the Realm SDKs about having really native objects. What does that mean? It essentially means that the way that you're building classes and objects today on your mobile apps, that basically extends to Realm. So here we've got a dog object that has a name, an age, pretty simple. With Realm, you can store that in a realm, a collection of native objects, and you also have the ability to manipulate it, work with that object within a transaction. In addition to that, we also have query capabilities built in that allow you to filter or view a subset of objects based on certain criteria. One of the things that's actually a little bit new for Realm and gives a lot more flexibility for the SDKs are some of the new data types the team has been working on. So specifically, we've added support for dictionary types, the ability to have more unstructured objects as a part of your model, mixed types, sets that can be one of a couple types, as well as sets and UUIDs. And in part, especially with the dictionary and the mixed types, this makes it really easy if you're dealing with data that's unstructured or semi-structured, which is especially helpful if you're syncing data to and from Atlas that maybe has a little bit of polymorphism or is not always structured in the exact same way each time. One thing that's a little bit unique about Realm, in addition to being so object-centric, is its real-time and its reactivity. So specifically, the way that I described where you can query a set of objects, you could also look for changes on those objects. And specifically here is an example in Swift and Kotlin of how you can look at a set of dogs to see if a property in any of those dog objects has changed and react to it. And this is really useful if you are propagating changes, from one part of the application to another, but it's also key for working with synchronization. So specifically, the way the event loop works in the Realm SDKs is you have these write transactions, which I talked about before. You're manipulating data. This can also be when events are coming from cloud or coming from another system into your application. Those transactions will modify the underlying storage and modify a realm that you're working with. They also may update objects which are part of a query that you're listening for updates on, and that can trigger a notification which you can respond to in the UI or by running logic to handle the change. Now, what this means is that as you work locally or as your device is accepting changes from the cloud, you have the ability to work in real time, to absorb those changes quickly, to react to them in the UI. And this is one of the things that really makes it simple to build an application that feels reactive, collaborative, and that doesn't feel sort of this, standard, very API-driven, high latency model that oftentimes is the default when you're building a mobile app. So starting to shift a little bit to the cloud, if you were building that model traditionally, where you were moving data from a backend to your local storage, your local database, and thinking about how you actually worked with those objects, typically what you would do is you would take the object from local storage, you'd have to have it work alongside your application. If there were a change to it, you would have to probably convert that to JSON, hit a REST API. You might also have some sort of queuing system or business logic where that change got merged, or as different apps collaborated with data, you had to rectify different changes as they came in. And then finally, you would propagate that data to a database and store it on your backend. Now, along there were probably a couple of other shifts as you manipulated data, as you prepared it for other formats to be stored. And then the same process would happen in reverse. So having to take changes that happen in the database and then action on them, sending them to an application, all the while converting from what the data looks like on the back end to what the format you needed on the front end is. And across all of this, you need to be thinking about network state, marshaling data, handling different error conditionings, which makes it pretty difficult to write really good, resilient, reactive applications. Now, what we try to do with Realm synchronization is actually take care of a lot of that for you. Make the transition from a local native object that you're working with within your application to the object that's stored in your database seamless, happen automatically, and have built-in things like conflict resolution and the ability for multiple devices to work along the same data. And to actually start building with this and to have data move from your MongoDB instance to Realm, you really just need to do two things. You need to define a little bit of a mapping between Atlas and your application, so that transition from the backend data to your application can happen seamlessly. And you need to do a little bit of work to define the permissions. So, most people, when you're developing an application, you don't want to just open up your database for everyone to read to, write to. So we make it really simple to provide some permissions and some structure to that. To take a little bit of a look at what that actually looks like in practice. With Realm Sync, you're moving data between the Realm SDKs and MongoDB Atlas. Sync is making that happen automatically, but it still needs to make this journey between what the data typically looks like in Atlas, which is JSON, and what it looks like on the Realm SDKs, which is a native object. So on the SDK, let's say you're doing a to-do list. You might have a task that looks something like this. It's got a name and a few properties. And what you need to do is map it to Atlas. Now, we actually, on the Realm side, use a concept called JSON schema, which a lot of folks are probably familiar with. It's used pretty broadly. And this just lets us say, this is the structure of our object in terms of what types. It also gives you some validation logic, such as whether a field is required or not. And what this lets us do is, on our end, map between that object that you have on the SDK and what the data will actually look like in Atlas. Now, there are two different ways that we offer for you to actually build this mapping. We understand that not everyone wants to write a bunch of JSON schema in the middle of building your application. So there are two ways you can approach. The first is if you're starting with data in Atlas, we offer schema generation, which will scan all of the collections in your database, or only the ones that you want to sync, and generate the JSON schema for you based on the data that's already stored. From there, the JSON schema will also generate data models for the SDKs, meaning that with just a click of the button, scans your data and generates objects that you can actually use and start syncing with right away. Now, the other way that we allow you to develop is if you're starting on the other end. If you have a SDK, if you have an application with data models that already exist, and you're thinking about, how do I get these to my backend? So we have a schema developer mode. And what that lets you do is start sending changes from your SDK, sending those to Atlas. And what it'll do is accept those changes and infer the schema as the data is sent from the SDK to MongoDB Atlas. And the same way that you just sort of started with what you had already, you'll start with the objects, you'll get JSON schema, that data will be sent to Atlas, and when you feel like you sort of tuned your model correctly, you can turn off development mode and it will prevent devices from sending any schema changes. Now, once you've set up this mapping, you're pretty much ready to start syncing your data, but you just need to think about permissions and how your data is sent from Atlas to the device first. So we talked very briefly about what realms are. Realms are a collection of objects that live on the device and have those nice built-in operations, the read, the query, the ability to listen for changes. So if you have a bunch of data in Atlas, how do you start thinking about which app can open which subsets of data and making sure that users only have access to the right data at the right time? Well, essentially what we let you do today is choose a partition key. So the ability to look at a field within your data and say, this is the field that I want to split my data across, and each unique value will be a different realm that users can open up. Now, what that means is that then users can open a realm like this. In this case, we might say, let's take all of the Square documents and let's sync those over to our mobile application. So the user would get those squares. And essentially what we have is the ability to define read and write permissions based on the partition. So you could say something like users with a certain permission, a certain part of the metadata in their user object or some characteristic from their authentication have the ability to read squares, have the ability to write squares, or even have the ability to read the circle partition, but not write to it. So you won't go too much in depth to that, but really the big takeaway here is you have the ability to define a partition across your data. That gives you well-defined realms that you can open on the SDK side, and that lets you start syncing data with permissions at the partition level and at the realm level. Now, one of the things that we've seen is that sometimes people want a little bit more flexibility. Sometimes you want the ability to have your data defined a little bit more dynamically or have maybe more complex relationships. Maybe your data is a little bit like hierarchical in nature, or you want to query across multiple fields. So the team is actually hard at work on something we call flexible sync. And this is the ability to open realms defined by a query as opposed to defined by more of a static partition. And the way that that works is you'll define what fields that you want to query, and you'll be able to open a realm via a query on one or more fields, update that query over time, and you'll have permissions at the collection level as opposed to more static permissions at the partition level. Um, so this is something that we've actually are just announcing today at MongoDB.live. We expect that it'll be in beta later this year, so keep a lookout. And we, see that a lot of the partition approach works for almost all cases, but there are definitely some cases where you might want a little bit more flexibility. And so for folks that are looking at that, that's something that we're hard at work on, and you should see some changes there soon. So in this case, if you were querying on the color field, you would actually, instead of getting the squares, you would get all of the red objects moved over to the device. Now, you could even evolve this query saying, I want to query on red, color red, and shape circle, and subscribe to that. You could update that query later, and the results in your device would update dynamically. So these are all going to be options in the future that will give you a lot more flexibility, in addition to the scalability and a lot of the benefits you get from having the native objects and having data synchronized automatically. Now, moving a little bit from Sync to some of what we offer with MongoDB Realm outside of Sync, and specifically we tend to refer to these as the app services. There are a number of serverless services which make it simpler to build on your data in Atlas and around what you may be doing with Sync. The reality is that we know that your data isn't truly valuable unless you can work with it, open it up to other systems in a really targeted and well-defined way, and react to changes as they happen in the database. So specifically, we have serverless functions. We let you react to changes in your data or your application with triggers. We let you expose data through GraphQL and HTTP endpoints. And we have some built-in security and access controls that ensure that as you're doing all of these things, you could do so in a way that is safe and secure. So we'll talk a little bit about each of these things, services as well. Specifically on the trigger side, this is a little bit analogous to a traditional database trigger, if that's something that you're familiar with, but you can think about it as saying, a change happens in my database, and I can run some logic to respond to that. Specifically with Realm and triggers, that response is a serverless function written in standard Node.js with NPM support. And that's something that we've actually been working a lot on adding to the breadth of NPM support that we actually cover today. So today, most packages should work within functions, and we're working a lot on really streamlining the developer experience of importing, managing versions of packages as you develop your code. Now, what triggers let you do is typically take a change in Atlas and either propagate that data to another cluster, another part of the same cluster, integrate it with another system, potentially applying business logic, merging that data, adapting types or structure as it goes, or even notify on certain data changes, doing things like filing an alert, sending an email or a text message. And all of these are great things which you can do in a very scalable, low latency way with triggers. And it's a great way to take processes that might be done in batch today, might be a little bit more sort of on demand, and make them event-driven and responsive to your data in Atlas. And triggers also combine well with mobile synchronization. So as that mobile data is flowing in between your apps and your cluster, you could use triggers to really kind of take a handoff between the data as it's written to the cluster and integrated into other services and systems. Now, this is very much taking data as it changes and sending it out. We also offer REST and GraphQL services. And specifically, this helps you give a little bit more of an API-driven window into your data. So definitely something that is a little bit more for incoming requests as opposed to data that's changing. And what it provides is scalable API access, again, for services or tools that want to access, work with your data, whether that is through a HTTP endpoint that's a little bit more REST-like, or GraphQL. And for GraphQL, we actually have a generated GraphQL API that takes advantage of the schema that we talked about, generates a GraphQL API for you, can be done with the same sort of scanning your data to a generated API approach, and can also be extended with functions and custom resolvers. So that gives you a lot of flexibility right out of the box to have data in Atlas, create an API, and start working with that API to integrate your data into services, into tools, or even into more of like a data API or even a front end. So these are both great if you want to take the data, whether it's mobile data or other data in Atlas, and provide additional access to it from other systems and start working in an API-driven fashion. Now, one of the things that people ask when we talk about Realm is how do you actually build? How do you work with Realm in practice? So we've got a nice UI, looks great, has all the features. We even have things like editors for functions with built-in developer consoles so you can run your code. And this is great for, going in, getting started, really understanding the product and building up a POC, or going in and making, a small change or a tweak. But oftentimes when people see a UI like this, they're thinking about, this is a UI-driven product. I'd like to write code. I'm not going to work or develop in a UI. And because of that, we have very sort of code-driven approach to working with Realm as well. So everything that I'm describing, what you're seeing in this UI that I'm showing, it's all backed behind the scenes with JSON and JavaScript files. So you're able to export your application, and we even have a CLI, which really makes it seamless to work with whatever your local development environment is. So whether you're pushing or pulling app state, managing app configuration, in our new version of the CLI, which is recently GA'd, you have the ability to even call Realm functions or to tail the logs, which it makes it very easy for you to push some application changes and then be testing from things like, an emulator that's running locally or Postman, to really get a sense of, what's going on in my application as I'm testing, how's my logic behaving, and being able to see that in real time without kind of context switching between the local tooling and a cloud UI or browser window, things like that. We've also recently introduced the concept of environments. So what we often see is that when people want to work with a Realm application, they'll have a new branch that they work with for a feature. So they'll make a development branch. Then they might want to test that, push it to a testing environment, and make it promoted to a QA environment before it gets pushed to production. And what we've added to make this process more seamless is the idea of environment tags in Realm, making it really easy for you to understand which environments correspond and also have specific expansions in your function logic, as well as in your application structure, that will give you different values depending on the tag of the environment. So this is really useful if you are moving code across environments, if you want to test and maybe there's a different API key or a different collection that you want to be working with, or your logic is hitting a different endpoint based on whether it's in development or production. This makes it really easy to take into account all of those different things. And finally, we have code deployment. And code deployment gives you the ability to actually integrate with GitHub and keep your app state in a repository and automatically pull changes to GitHub, or if you're making changes in the UI, commit those changes to GitHub as they're made in the UI. Now, what this means is you get a really sort of seamless experience between your app state and your UI. We've also recently added the ability to roll back to redeploy an older set of changes. Let's say you deploy and there's a bug, or you want to actually go back to a previous version because of a regression. It's now easy to do that as well. So all these changes mean that you have a really holistic development experience regardless of which of the Realm services you're using. So hopefully this has been a really helpful overview of what's available within Realm, how you can actually use it to build better apps faster, regardless of whether you're building a mobile app and then thinking about how that data flows into the rest of your backend architecture, or just building APIs or triggers on top of your MongoDB data. We have a couple of other talks that are really great that I'd recommend you would check out if you want to get a little bit deeper into the Realm SDKs or sort of the code and configuration that runs Realm, as well as some booth demos that will really walk you through what an application looks like in practice. So I definitely encourage you check those out, and I'm really excited to see whatever you build with Realm. Thanks.